Okay, the Calculus of Basic Skills worksheet is due Monday, April 25th. Calculus of Basic Skills, I don't know what Monday, April 25th. And you are going to take a quiz, which will have 5 problems taken directly from that. From this. You do your worksheet, you're going to do 5 problems that are going to come directly from that. Yes, it's a white sheet. You got one a while ago, and I'm not sure where my extras are. We can try and find them at the end of class. Okay. Monday the 25th. Okay, guys, listen up. Mrs. Hersman and I are working on Senior Serve. Senior Serve doesn't just happen. We have to get together with a bunch of the other teachers from this committee, and we put it all together. Okay, so that's what we're going to be doing Monday. So on Monday, you will take your quiz, and then you're going to go to the lab. Or we might do something, yeah. We might go to the lab first and finish with the quiz because there's an overlap with Mrs. Hersman's class, which is okay, but it might be too many people in the lab at once. There's only 32 computers. So I think we'll do that first. We'll do that. I'm getting there. We're going to 1534. So we're going to go to 1534 lab until they come in, and then you come back here, and then we'll take the quiz. And you'll still have some extra time, but if some of you want to go back to the lab, it's up to the reserve. Now, what are we going to do in the lab? In the lab, there is software on the computers, and it's called APCD Calculus. There's also another one there, I think, for history or something. I forgot what that other subject was. But you want to go to the calculus one. You go down to programs, you know, press the start menu, go to programs, and you'll find it. I don't know if my reserve teacher will know how to find it. And on that CD, there's a lot of stuff. There's a practice test, and it's based off the 97, 98 exams. There's multiple choice, free response, so you could put yourself in a testing situation. We'll be there all week. But again, we're going to have to work it out with Mrs. Hersman. So some of you may want to work with partners and do problems together. We may have to do some doubling up. And there are tutorials. So if you don't understand those rotation problems, they have tutorials on there, and they have nice visualization. They actually show the curve rotating around the graph, around the axis. And then you can see the cross-sectional slices. You can see why they're circles, or see why they're washers, or see why they're cross-sections. So that's really nice, and explorations. Now what's really nice is that in the last few years, these things didn't work. The tutorials and explorations didn't work, but all of this did. The practice test, you could either do it in practice mode or test mode. But now, I at least tested it out, and these work. Now what's going to happen is there are bugs in it. So once in a while, your computer's going to freeze up, and you're just going to have to restart the thing. But it just is going to happen, or the program will freeze up, and just have to restart the program. And you may lose your place, by the way, on the testing situation, if that happens. But it's still worth doing this because it's just really helpful. Okay, so that's what we're going to do all next week. This is going to be Monday through Friday. If we don't need Friday, we won't take it on Friday, but we have it reserved for that whole week. And then we'll have study sessions on Monday night and Tuesday night. And Mrs. Hersman and I are going to be here all week anyway, so we may open up AB to Wednesday and Thursday nights next week as well. Okay? Then, study session. We don't have one scheduled for this week. However, Mrs. Hersman and I were talking about, I can't come tonight because I have my choir practice and it's for Easter, so I need to be there. So the study session, it won't be one today at all. But tomorrow, we can either do 3 to 5 p.m. or we can do, like, tomorrow. This is Thursday. Well, that's the question. And a 2-hour block between 6 and 9 p.m. Now, Mrs. Hersman is going to do this. I think that's a for sure. And I don't know how many people can come right after school. That's the reason why I do them at night. This Thursday, this week. Next week, we'll be here all 4 nights. So I don't know if the after school works at all for you or not. Or I can come back at night. But I need to know, and you need to make a commitment because it's 30 miles of driving, extra driving, which is a gallon and a half of gas. And at today's prices, it's a lot of money. Okay, so, yeah. $70 to fill my car. So I need to know which session you're going to come to. I was planning on staying after school, but if there's more people that can come at night, I can come at night. What do you have right after? Sports. Yeah, that's the problem. Next week it'll be in the evening, unless you want us to do something, right after school. We could maybe stagger it a little bit too. So this would be a possibility. Well, we'll see. I'll take a better poll tomorrow. Okay, so I think I've got all the announcements. Your exam is Wednesday, May 4th. And what I like about this time of the year, I'm a math teacher, so I like doing the problems. So I enjoy doing the problems. It's not a problem. But more than that, you start connecting some of the concepts. And you're going to look at problems and you're going to say, oh, I know how to do that. When we did the problems, you were confused. You go, oh, I don't know how to do that. But now you do. So it's just fun for me to see that growth, and what you've been doing. So what I would do today, I'm going to just review some things. And then we're going to do problems, and we did multiple choice problems. So I'll be consistent and do that all day. And then I will give you points based on how hard you worked in class today. I'm not going to collect it unless I really feel like it didn't work. Okay, but I would take notes on these things, because what are you going to do the night before the exam? No, you're not. You're going to have a nice dinner, relax, watch some TV, or play video games. You need to relax, because you know what? If you don't know it by the night before, you're not going to know it. But if you take the notes that I'm going to give you now, which kind of pulls the big ideas together, if you wanted to look over those, and I suppose you could print out my smart board in color, whatever. So where'd my notes go? Oh, so we're going to review on the schedule. It says a whole bunch of stuff, tangent lines and linearization, but then we kept going on because I could see the connections. So we got average rate of change, we got average value of a function, we got mean value theorem. So we kind of did all those things and still did like 8 or maybe 10 multiple choice questions. So these are big picture things. So when you're doing tangent lines, you know the equation of a line. That shouldn't be a problem, but let's write it. 2-point slope form. If you do y equals mx plus b, it's usually harder. I even start with point slope form and change it to y equals mx plus b if I need to, because it's not that hard. So that's what I do. And remember, slope is always a number. And I should have done that in the last class, but I forgot. Well, what they ask you about tangent lines often on the free response, is it an overestimate or is it an underestimate? I think Mrs. Hersman says, why don't I just draw the picture? I don't have to memorize it, but if it's concave up, that's an underestimate. And I forgot to do something in another class too, so you'll be more thorough. If my graph is concave down and I draw my tangent line, this value on the tangent line is an overestimate. They've even asked for secants. Do you remember what a secant is? Yeah, it's the average rate of change. So what is the slope of the secant? I know that there was one problem that asked if that was an overestimate or underestimate for the real value. Just draw the picture. Yeah, it's different. This is going to be an overestimate. So when you think about it, and I know when you look at the words and the symbols, it makes you nervous. Makes me nervous too, by the way. But then when you draw the picture, you go, oh, it's not hard. And so this is f of b minus f of a all over b minus a. And that's got a lot of connections to other things they may not have realized. This is the slope of the secant. And I think Lauren said it's also the average rate of change. Yes. The review sessions, the students who come find them beneficial. I know you can't always come. I know that. And Mrs. Hersman doesn't like to video them, so she doesn't. I didn't either last night, but usually, I mean, I can. So what if I do the secant line of this concave down one? The blue one is an underestimate. So you're right, it's the opposite. Whoops. Sorry. Okay. So when you do the secant, it's the slope at the endpoint, using the endpoints. You talk about the concavity, and I would maybe include a picture. Yeah. Look at the scoring rubric. That's the minimum, really, of what you have to say. You could say more. See, I would say this is an underestimate for the tangent line because it's concave up. And then I would draw the picture because that's how I'm going to do it. If you look at the scoring rubric, that helps. Well, we also have, and when I think about it, this picture might work. I could draw my tangent line here, and that's a special name. If these are parallel, do you remember that? Let's call that C. What's true about these two slopes? They're the same. So if I take the slope of the secant, f of b minus f of a, this is going to be important in a moment, over b minus a, that's equal to f prime of c. That's called the mean value theorem for derivatives. What is f prime of c? That's what? That's a derivative, right? So f prime of c is a derivative. And what is a derivative? A lot of ways you can describe it. It's the slope of the what? Of the tangent line. What is it in terms of a rate of change? This is an average. This is a instantaneous. I don't like this word because I always spell it wrong. It's too long. Okay, so what this is saying in my mean value theorem is that the average rate of change equals the instantaneous rate of change, someplace. Someplace, yes, it should come back. That's what's nice about this, because then things come back. So we have now an average rate of change right here, which is the slope of the secant. We have an instantaneous rate of change, which is the derivative. And there's another word that we have to use, and I always have to think hard because I'm going to get them mixed up. It also involves an average, and it's the average value, not a rate, of a function. Do you guys remember what that is? You're going to average the values of the function. You're going to average the y-coordinates. So you would, if you had all of them, you would add them all up and divide by how many you have. I mean, it's text, not games, but text message. So I know what it looks like. Okay, average value of a function. That's adding them all up and divided by how many you have. Do you remember what that is? How do you add them all up? That's an integral, right? Yeah, integral from a to b of f of x dx. And I don't want to go through how you arrive at this, but what's the equivalent to dividing by how many you have? It's the width of the integral, b minus a. So there was the problem with the left turns, or no, I'm thinking the concert one, that one. There was a concert one, and you want to find what's the average number of people waiting in line. What's their average wait time? So you take the total time of everybody, which is the integral, and divide it by how many people are waiting in line. And that gives you your average wait time. And that should make some sense. Pardon? The wait time was adding this up. You know how fast it's changing or something like that. I don't remember the problem. Yeah. So you have to add it all up. Now what's amazing about this whole thing is, we're going to go to mean value theorem because it's connected, is that this average value function is related to that. So we're going to review the fundamental theorem of calculus too. Now, geometrically, we can do. Let's do the fundamental theorem of calculus. You remember this? The integral from a to b. This is Riemann. He said, I don't. Actually, Riemann. This was a theorem. And he found out that if you found the antiderivative of that function and evaluated at the endpoints and subtracted them, that's how you can find the area under the curve. So this is capital F of B minus capital F of A. So what would this look like using the fundamental theorem of calculus? This would be an antiderivative, F of B minus F of A over, in this case, B minus A. That looks kind of familiar. That looks like a what? Change in y over change in x. It looks like a slope. Yeah, rate of change. Well, that's capital, that's little. So this is the derivative version, and this is the integral version. So if I wanted to change this slightly and make a special note of this, what if I integrate a derivative from a to b? What's the antiderivative of f prime of x? F of x. So that looks like little f of b minus little f of a. And I don't have a b minus a because I'm not doing an average value. So that's kind of connected up here too, if you think about it. Now I'm really going to connect it. Let's do the mean value theorem. And that's where it gets connected. This was the mean value theorem. Where was that? This is the mean value theorem for derivatives. There's a mean value theorem for integrals. And how I remember this is that the slope of the tangent line has to equal the slope of the secant line. That's how I remember it. And so the average, the mean value theorem for integrals I can remember as well. Mean value theorem for integrals. So I'm actually picking up a lot of stuff here. It's probably focus on the fundamental theorem because that's really important. Okay, mean value theorem for integrals says that if I have a curve, and what's nice about that AP Calc CD is there's an exploration on this, and there's a slider on it. So you can change the function and see where this, what I'm going to do here, is happening. So there's A, then there's B. And we have the area under the curve from A to B. We know what that is, of f of x dx. There is an exact answer. And if you try to find a rectangle, you can find a rectangle such that the area of this rectangle is exactly equal to the area under the curve. I'm going to call this point C, then the height here is f of C. So that someplace, there has to be a rectangle here, since the area of this blue rectangle is exactly equal to the area under the curve. Because you know that the area of the curve is bigger than the green, this green rectangle, right? And it's smaller than that one. And since area is continuous, you can't just jump from an area of 1 to area of 2. It has to go through a value. There has to be some rectangle in here that will exactly fit that. And so the area of that rectangle is this. It's f of c times b minus a. It's someplace. It could occur near one of the endpoints. So if you go and look at the exploration, you can actually see it. They draw the little rectangles. You use your slider and you can change the function, and you can see how the rectangle changes. Kind of cool. And I'm so glad it works. What if you take this equation and divide by b minus a? Now this is the mean value theorem. But I can change its form by dividing by b minus a. And I get the average value of a function. Notice I have to say that slow or I'm going to say it wrong. So f of c is equal to the integral from a to b of f of x dx. Okay, so I got average value of a function. What if I did this one? This is the average value of my derivative. Oh, it's not how I want it to be. F prime of c. And then I'm going to differentiate both functions on both sides, right? If I take the derivative here, I take the derivative there. Okay? What is this? Using the fundamental theorem of calculus. What's this one going to be? What's the antiderivative of f prime? F. And you're going to evaluate it at b. You can evaluate it at a over b minus a. This is the derivative form. This is equal to f prime of c. Guess what? That's the mean value theorem for derivatives. These are the same things, but one's in a derivative form and one's in an antiderivative form. They are not going to tell you which form. I remember that the first time I did this, I go, how do I know which mean value theorem? Well, it all depends on what you're given. But I think that's kind of cool. It took me 3 or 4 years before that connection came to me. And I always find new connections every year. And if you look at it this way, this is still the mean value theorem because this is equal to f of c. That's the average value. That's the antiderivative. This is the derivative form. Oh, sorry, f prime c. I was going to mess that up. It's the same thing. And so where do we use that? We do use that, actually, because, and this is a good time to talk about velocity and acceleration because we haven't talked about it at all. If S is my position, okay, so I'm given the position, what's the average rate of change? So, you know what that is? That's the average velocity. How do you find the average velocity? Do you remember? Because you're going to be asked this question. No average. It's S of T2. That would be instantaneous, right? All over T2 minus T1. Some of you tried to add them up because you're thinking averages, but you can't. You're given a position. What if you're given a velocity? And how are position and velocity related? Velocity is what? The derivative of the position. I'm going to show you it's the same thing, but it depends on what you're given as to what you're going to do with it to get the same answer. So what if you're given v is the velocity? So we're going to give them the velocity here. And I want the average velocity. These words match. What would I have to do if I knew the velocities? I want the average velocity. I would add them all up and divide by how many I have, right? How do you add them all up? You integrate from T1 to T2 of v of t dt, and then you would divide by how wide the interval is. This is the average value of a function. See, this is an average rate of change. This is the average value of the function. They're so similar. I can see how you can get them mixed up. And that's T2 minus T1. Now here's the aha moment. What's the antiderivative of the velocity? Position. So you can find the position at T2 minus the position at T1 over T2 minus T1. It's the same thing. If you're given the velocities, you want the average velocity. The words match. You're going to integrate. If you're given the position, but you want the average velocity, because I know velocity is a derivative, I'm just going to find the slope. Maybe that's the way to remember it. But it's the same thing. You just have to be careful which one you're given as to whether you integrate or take a derivative or find the slope. So I think that's I think it's really cool. And the mean value, it's the mean value theorem for both of them. But they're just different forms. I think I got everything. So you could go ahead and print this out, especially in color, which would be nice, and add the video. Okay. So you say you didn't have to show any work on 2008, number 3. You should have a lot of work. So we're going to go over the 2008 exam. And we have about 20 minutes. We'd be surprised how fast, and I'm going to talk you through it. Now, keep in mind that when you are on the exam, if something looks too tough, skip it. No, the first one isn't that bad. This one, I'll show you why it's bad. First off, I can't take the derivative in my head. Because if you're taking the derivative and multiplying derivatives, it's just wrong. Now, I have the answers. I thought we gave them out to you, but we didn't. At least I don't find them. So I'll have this run for you. It's also, I'm the secretary scanning this, so these answers will be up online, so you can check your work. But what's really nice is to also look at the total percent correct. So problem 3, 39% of the people taking this got this right. Well, there's worse ones. 22% got it right. But we just have to find the derivative. And I don't think the problem is in the derivative as much as it is in the algebra. So it's x minus 1 times the derivative of x squared plus 2 cubed. So first I do the power rule, x squared plus 2, and then to the what power? Second, and then times the derivative of the inside function, which is, no, 2x. You see why? X squared. Okay, plus, and then I leave this guy alone, x squared plus 3 cubed, and then I time, I want to make it 3, I don't know why, but it's 2. I'll notice it. When I try to factor it, I'll find a real problem. X squared plus 2 cubed, oh, I'm a little dyslexic, and times the derivative of x minus 1, that's easy. So, I can't do that in my head, and I certainly can't get to the answers that are there in my head. There's no way. So my guess is, if you did do it in your head, then you just took the derivative of that times that. That's my guess, and that's one of the answers. But that's wrong. So, f prime of x. Now, what I'm going to do is there's a common factor there. I don't want to multiply that out. Because if you look at the answers, they're all factored. So, and we've never done this. We've never practiced this. I can give you problems practicing if you want. So I'm going to factor out x plus 2. What's the most number I can take out? I got 2 there, 3 there. I'd like to do 3, but I don't have enough, right? So I can take out 2. And now, what am I left with? I'm left with, I'm going to cover that up, x minus 1, except that's kind of in the way, times 3 times 2x. And then I'm going to cover, that's not gone. There's still what? 1 left there, plus x squared plus 2. Now maybe you can go right to the answer without showing any work. Oh yeah, I just copied it. I will catch that. This is 6x, right? So, because I'm teaching this, I'm going to do all the work. But you probably could by now guess which is the right answer. And you don't have to show your work on this, and there's no penalty for guessing. But I'm trying to make sure you understand it. So I'm going to do all the work, but you could probably guess and stop right now, right? And that saves you some time. What's 6x times x? 6x squared. Then I distribute here, minus 6x plus x squared plus 2. And what's this going to give you? Now you should be able to find the answer there. 7x squared minus 6x plus 2. And that should be answer D. I can't do that in my head. You know, some I can, some I can't. Number 4 I could probably do in my head. But for those who don't, number 4 is B. Yeah, we want me to do just exactly what we did in the other class. B, as in boy. I'm going to do a U substitution. I want to get it right. Now, you could take the derivative of all the answers there, because 4 is an integral, but honestly, I think it's faster to do the problem. Now, they don't have to put those parentheses there, but we will. And that's a composite function. So it's not just the cosine of 2x and the sine of 2x. Heaven forbid I'm going to get my signs wrong. I'm going to do a u substitution. What would you like u to be? It's composite. I got a linear function inside a trig function. 2x. What's the derivative of u then? 2 dx. So when I solve for dx, what's going to go out in front? 1/2. So it's 1/2 the antiderivative of the sine of u plus the cosine of u. And this is du. I'm glad I have the answers now so I can find out how many got it wrong. What's the antiderivative of the sine? Negative cosine. The derivative of all the cofunctions are negative. How do you know if you did it right? If I just write cosine of u here, I'm going to stop and check. What's the derivative of cosine? It's a negative sine. Well, I don't have a negative, so I better put it in. Plus, and the antiderivative of cosine is sine. One will have a negative, one will not. And then I'm plus c. Almost forgot for c. So then I'm going to go ahead and substitute this back in. So it's minus the cosine of 2x plus the sine of 2x. And then they might have, did they manipulate this? Because I don't have answers in front of me. But they probably did this. Sine of 2x minus the cosine of 2x all over 2. I don't know, but it should be b. That's what the last part told me. They have the 1/2 in front? Okay. You should be able to switch them. Oh. And now let's see. This is number 4. 95% of the people who got 5s got this right. 86% of the 4s got it right. 74% of the 3s got it right. And 60% of the 2s got it right. And 37% of the 1s got it right. That's kind of interesting. 70% got this problem correct. That is good. I think that number 11 looks like the highest. That was 77%. It's kind of interesting to read the statistics on this. Okay. But we're going to go in order rather than the way we did it in other class. Yes? You should have them done because what I have that I'll print up for you is a way for you to score them. So score yourself so you have an idea what you would get on the exam. You need to do the FRQs too. We've done some. You should be doing 2 FRQs a day. That's a half hour. And I know that other AP review people are saying you have to spend 2 hours or whatever on my class. I'm saying a half hour. And you'll get really good results if you do that. We get the best because you can study for this exam. And now, by doing this, you're actually going to learn how to study. Some of you never knew how to study math. Okay, so number 7 was a great problem. I like that problem. Did you get number 7? We need to do something in between? We will. But 7, you're given the velocity. This is a non-calculator problem. Why the numbers are nice? They're very nice. Okay. And they're saying when the time is 0, this particle is not starting at the origin. It's starting at 2. And this is in the x direction. Okay? It's not going up or down, it's just going sideways. And then, where is it 1 second later? So that's what it's asking. And there are a couple ways to do the problem, to think through it. I'm going to do the fundamental theorem of calculus. And the fundamental theorem of calculus, well, before I do that, what's the antiderivative of the velocity dt? That's your position. I'm going to call it x of t plus c. And I don't think I can use that to do this, although you could think of it that way. So I'm going to use the fundamental theorem. Now, I know where it is when t is 0, and I want to find out where it is at 1. And this concept is used throughout the exam. You will see this in multiple places. If I integrate v of t dt, I will get the antiderivative, which is your position, evaluated at 1 and evaluated at 0. I want to find this. What's your position? What's x of 1? Nice. I can integrate that. I know how to do that. And do I know x of 0? Yeah. Solving for x of 1, just because I like to do it that way, It's equal to the starting position plus how far it travels between 0 and 1 second. You could do it that way if you want to think it through, with physics and logically. Otherwise, you can just use the fundamental theorem of calculus. And that's how they use that. And I don't know if you remember in chapter 5 where they said, write a new function using an antiderivative of the fundamental theorem. And it looked like this. And you were looking at, why would I do that? Well, this is why you do it. So what's the starting position? 2. You didn't start at 0. So if those of you who want to integrate this, that's fine. And you're going to go 0 to 1, and it was 3t squared plus 6t dt. Okay? So you could say, well, I know it travels so much distance. I'll integrate that, find out how much distance it travels, and then I have to add that onto the 2. They didn't start at home. It started someplace else. Does that make sense why you have to add the 2 in there? Because they often they'll give you the answer to this integral. That will be one of your choices. And then you have to remember to add 2. And you will see that. Actually, that is one of those problems. There are 10 problems that are on the exam that you have to get right to get a 5. This is one of those 10. It won't happen. But these are the common ones that they're looking for, because I can think of the other problem very easily from the 2003 exam, and it was more of a word problem than this one, like Sally did something or whatever. Okay, so we're going to integrate this, and we're going to be stupid. What's the antiderivative of 3t squared? If you're tired, it's the end of the exam, actually it's the beginning of the exam, you can do that. Nothing wrong with it. Or you can just say, oh, it's t cubed. Same thing here. 6t squared over 2. Evaluated at 0 and 1. Be careful when you find antiderivatives and evaluate at 0. A lot of times it's 0, but not all the time. So don't assume that if this is 0, that it's always going to go away. It doesn't. In this case, it does. So it's 2 plus, the 3's are going to go, 1 cubed plus, and this is going to go, so it's 3 times t squared, 1 squared. What's that add up to? Then that's 0. 2 plus 1 plus 3. 6. Yes, the 4 is there because people didn't add in the 2. That's why 4 is a choice. Let's see, this was number 7. So the answer is B. 67% of the people got it right. Pretty high. Yes. Not necessarily quickly, but yes. And remember, about half of the BC exam is the same as yours. The only way to know is to talk to them. Oh, I'm on the wrong page. Oh, 6 is a good question that nobody asked me about. They probably should have. Well, I won't write all the choices, but I'll write the function. Now you know there's going to be piecewise functions. And now you may use L'Hopital's rule here, because if you plug in 2, what you get here? You get 0 over 0. When you get 0 over 0, you can then use L'Hopital's rule and say, I want the limit as x approaches 2, and that'll be 2x. Take the derivative of this one, take the derivative of that one. You're ratioing the slopes of these curves at that point. And so the answer is 4. Clearly the limit exists. So I hate these questions because if you look at your answers, it's combinations of these. So f has a limit at x equals 2. True. So the number 1 is true. Number 2, f is continuous. What has to be true for this to be continuous? Remember that the limit as x approaches c of f of x must equal f of c. So the limit on the left side, if you asked to do this on a free response question, you would write this. You are not going to not write it. You're going to write it as that equal to f of c. What's f of c? Not 1. Oh, sorry. I've been doing too many study sessions. Yeah, it's 1. Sorry. Switch my x and y. So is it continuous? No. False. Then you look at the next one. Is it differentiable? What has to be true to have a differentiable function? It must be, it has to be continuous. How do you take a derivative at a point that doesn't exist? It doesn't make sense, does it? How can you calculate a derivative if the point's not there? So the only one that's true is 1, which is answer A. How about 8? Do you need 8? The answer to 8 is E. 61% got it right. E. Do we need to do that then? Okay. So this is number 8. F of x. In fact, your score on your AP exam is directly proportional to the amount of time you put into doing problems. I'm reviewing the theory, but you pretty much know. They like to have concept tests, by the way. Okay, so I'm trying to find f prime of pi over 9. And again, this one I have seen in other forms. Maybe it was a sine, maybe it was a tangent function. And I think the problem with this is going to be your trigonometry. I don't think it's the calculus. I've seen this question on every year. So you know you're going to have something like this. So nail it down. June 97, 98, 2003. You'll see the problem. You go, oh, yeah, it's just like 2008. So what's f prime of x? The derivative of the cosine is negative, because it's a cofunction, sine of 3x. And then you have to do the chain rule. Did you remember the 3? Okay. And so I now need f prime of pi over 9. So this isn't that hard a question, is it? So it's negative 3, the sine of 3 times pi over 9. What is that? Pi over 3. And when you start your test, you're going to draw your triangle. And I'm going to actually put my 30-degree angle here because I'm happier with it there. This is 2, this is 1, square root of 3, although I'm not happy, but... Oh, I'm trying to get the sign on this one? Yeah, it took the derivative, right? Okay, so it's negative 3 times, the sine of pi over 3. What's the sine of pi over 3? Not 1/2. Square root of 3 over 2. I don't use them for derivatives. So the answer is E. If you did B, you lost this 3, and you lost this sign. Do we have time for one more? We have 13 and 15. Let's do it in order. Let's do 13. We got time for one more. And then tomorrow, we're going to do fundamental theorem problems, and we need more multiple choice. But try them. And like I said, I will put the answers up on the web today. Now, there are 2 ways to do this. I can put in the log function first and then differentiate, or I can differentiate first. Actually, easier to differentiate first. Chain rule. What's the derivative of f? It's f prime of ln of x. And then you have to do times the derivative of the inside function. What's the derivative of log? 1 over x. Okay, so guess what I got to find? I got to find f prime of x. I think it's the function notation that's bothering me. F prime of x is the derivative of this, which is what? 2x plus 2. What are you going to put in for x? ln of x. So this is equal to 2 natural log of x plus 2 times 1 over x, or 2 log of x plus 2 over x. You could have substituted it in first. So f of log of x, I think it's just harder, to tell you the truth. I did both ways, is x squared, so it's the log of x squared plus 2 times the log of x. What's the derivative of this one? It's 2 times log of x to the first power times 1 over x plus 2 times 1 over x. It's the same thing. You tell me which is easier. This is more concept-based. First one's actually easier algebraically. And it is time to go. If you want to see more multiple choice problems, they will be up online from my last class. Okay? We didn't get as far, but that's okay. Everybody gets their 10 points for today. Everybody gets their 10 points. Don't you love it? Oh, wait. Yes.